Hello! Hi, everyone. Thank you so much for joining us on the LIUniverse today. My name is Charles Liu. You are, of course, welcome to call me Chuck. Thank you so much for being here today, and I want to introduce first our wonderful co-host, Allen Liu. Allen, how you doing?
Hey, doing good.
All right, read anything good lately? Any cool books, shows?
I've been reading Ministry for the Future
Ooh,
by I think Kim Stanley Robinson.
aha.
It's about like climate change and stuff, but like from a sci-fi perspective. It's pretty cool.
Ooh. And we are so glad to have with us as our special guest today, Dr. Alexandra Greenbaum. Alex, hello.
Hello.
Thank you so much for being here today. Please tell the audience who you are, what you've been doing, where you've been, the kinds of stuff. Get us some orientation of the cool stuff that you have done and the cool place that you are now.
Okay, great. So I am an astronomer. I got my PhD in astronomy and did a postdoc. And then I went to industry for a little bit, but I was really missing astronomy. So now I'm back. Now, recently, I'm a staff scientist at IPAC at Caltech, working on the Roman Space Telescope mission,
Cool.
specifically the coronagraph instrument on Roman.
Fantastic. IPAC stands for what exactly? Infrared something?
Infrared Processing for Astronomy Center. Maybe I got that right. I'll double check that.
Alan, help us out on that. What does IPAC stand for?
Okay, I can double check that
Okay.
real
While,
quick.
while you do that, I just want to pick up on this coronography. Did you say you're working on the coronagraph on the Nancy Grace Roman telescope?
That's right. So Nancy Grace Roman Telescope has two instruments, primarily the wide field instrument and the technology demonstration, the coronagraph instrument, which is going to pave the way for future space coronography to be able to, take pictures of planets that are similar to those like in our solar system.
Wonderful. So your expertise is in taking really, really clear pictures using telescopes.
You could say that. um,
Yeah,
I would say is taking advantage of what we know about telescopes to look for hidden information, to look for the really faint signals that usually get washed out.
yeah. All right. So yeah, I was on the website. It says it stands for Infrared Processing and Analysis Center.
I always get it wrong.
All right.
The A always throws me.
Yeah,
Okay.
because A should always stand for astronomy, right? Why should it
Right,
stand for
right.
anything else ever? Analysis? Are you kidding me?
Don't show my boss. Yeah.
Yeah. They say they have grown beyond its inaugural name
Yeah.
on the website,
Yeah.
so it's more than just that.
That's
Okay.
why it's hard to look up. It's IPAC now. Yeah.
Let us start now with today's cosmically cool thing. And it's got to be the picture of Sagittarius A Star that has recently come out.
Yeah.
For those of you who aren't in on the lingo, I apologize for using technical terms. Sagittarius A Star, which is often written Sgr capital A asterisk, okay, is the technical name of the supermassive black hole at the center of the Milky Way galaxy. And the team at the Event Horizon Telescope has just recently put out an image of that black hole, which is totally amazing, but also a little bit hard to understand. Even some of my colleagues in my department, who are incredibly talented and brilliant physicists, they're like, wait a second, that doesn't seem like what a black hole ought to look like. And it's not, sort of, unless you know what you need to look at. But Alex, since you are an expert, tell us, when we look at that bright ring, right, followed by that dark circle in the middle, the black hole is not even either of those things. The black hole itself is actually inside the dark ring, kind of hidden behind the photon capture radius, right?
Right. So we're getting just the light that is able to actually come and hit our telescope, or telescopes, as it were. This very, very cool detection
Yeah.
and image.
Right. So what is the deal with the telescopes? I mean, we know that the Event Horizon Telescope is actually a network, right, of large numbers of telescopes all over the world to put together a picture together using a technology called interferometry. You were just mentioning that earlier. Tell us what that is.
Yeah, so it's pretty clever. If you want to see really, really small details, like being able to see the light that's closest to the black hole there, you need a really, really big telescope. And in this case, you need a telescope that's basically the size of the Earth.
Wow.
And instead of trying to build a big dish that's that big, which would be impossible, you can actually correlate the signals from different telescopes all over the world together very precisely and put together an image of what all those signals are measuring.
But does that mean that actually this Event Horizon Telescope uses the internet to connect one another? Is it actually a worldwide telescope type thing?
So I don't know the details of how they actually do the signal correlation, but I believe that they have really, really good clocks at each site, and they measure that signal, and then I think they may just bring the signals together physically and sync them up and then correlate them.
Wow.
Yeah, I think they like carry them around on hard drives or something.
Whoa.
Right.
So,
Certainly, historically, that's how it was done. I think it's still done that way. Yeah.
so it's actually still like more precise to carry them around in a suitcase or something and then bring them together somewhere to process them, rather than say try to use the internet to sync them up.
Maybe. Like I said, I'm not 100% sure, but maybe I can imagine that there's a lot of data, right?
Right.
So you have to think about the right way to handle all that data and bring it together and get the timing perfect.
Yeah. Anyway, in any case, it's a remarkable and tremendous technical effort that was made to make it happen, and I'm super psyched about it. All right, let's go to a question. Alan, is there a question from somebody that we can give Alex a crack at the answer for?
Yeah, we do have another question. Before that, I'm going to say I did look up the amount of data that the Event Horizon Telescope produces. It's around 64 gigabits every second.
Wow.
So enough to fill one of the highest capacity iPhones every 2 minutes or so. And one of the telescopes in the Event Horizon Telescope is at the South Pole, where there isn't high-speed internet, so they just have to fly it in on hard drive.
Wow.
There you go.
Okay.
Yeah, we've got some questions. The first question is, we were talking a little bit about telescopes and their construction and their operation. So this one is a question from Isaac, who asks, how does JWST differ from Hubble?
That's a great question, I think. Hubble has had such an impact on all of our lives, I think, no matter who you are and what you do. But in many ways, Hubble is a different kind of technology, right? Hubble is a single mirror, right, which makes certain things convenient. But making a mirror even bigger than Hubble would become very heavy and very expensive and potentially not be as good of a mirror. So for one, James Webb Space Telescope has a much bigger mirror, about 3 times the diameter. And in order to have this mirror, it's actually made up of 18 different mirror segments that all align together to form the primary mirror. Another way that it's different from Hubble is that it's an infrared telescope, whereas Hubble is mostly in the visible.
Oh.
And James Webb can look well into the infrared, into the mid-infrared, and it's giving us different information about a lot of the same things that Hubble has looked at, but enriching our understanding of the universe.
Wow. When you say that something is sort of multi-segmented as a mirror like James Webb is, does it look kind of like an insect's eye or something like that? One of those things, where they're able to look in multiple directions, sort of?
Yeah, well, I guess you could, but the idea is to make it so that it acts like a single mirror.
Oh.
It's very powerful if you can shape the surface so that it was like a continuous mirror. You could have it pointing in different directions, but then you wouldn't get that resolution, just like we talked about how the Event Horizon Telescope takes advantage of, the resolution of using the whole, size of the Earth.
Yeah.
By forming the mirror that's larger, it gives it better resolution.
I see. Oh, very cool. So even though it's not round single piece, it's as if it were a single piece. It's just really big. Wow.
Yeah.
Wow.
Thank you. And then the infrared part, I wanted to ask you. The sun, right, and light bulbs in our house and so forth, the LED kind anyway, they emit primarily visible light radiation, the kind of stuff that the Hubble Space Telescope is primarily able to sense best. So, what are the kinds of things like around our world that emit infrared radiation that James Webb would be really good at detecting?
Oh yeah, I mean around our world, anything. If you've ever looked, at a heat sensing camera, a thermal camera, you can see things are glowing in the infrared that are hot, that are of different temperature, and we can take advantage of that with JWST to look at things that are emitting more in the infrared that are a little bit cooler than like our sun. This is everything from stars that are cooler than the sun
Yeah.
to some of the earliest light from the universe,
Woohoo!
and looking backwards in time. It's very exciting.
Oh,
Because the light's been stretched, right? Like it was visible light, but because of the expansion of the universe,
Right.
it's all stretched out to those colder and redder wavelengths.
cool. So, going from Hubble to James Webb Space Telescope is a generation, but now we're going from James Webb to the Nancy Grace Roman Telescope, which is what you're working on. So, this is a great way to sort of launch into that point. Now, we should, of course, make sure that everyone knows that Nancy Grace Roman is a different person from Nancy Grace. So you've seen Nancy Grace maybe on TV doing news type stuff, right? But Nancy Grace Roman, who was this wonderful Nancy Grace Roman person, Alex?
Nancy Grace Roman was a real pioneer of space astronomy. She was really important in launching the space astronomy program at NASA, and kind of the reason we have Hubble and James Webb and now Roman telescope. So she's a very key character in all of that, and
Wow.
an astronomer. Yeah.
How come we've never heard of her until now? Well, I'm glad that NASA put her name on a telescope, that's for sure.
Yeah, that's a good question. I know that her name has been on some grants associated, especially with instrumentation, for people who work on that kind of stuff.
Ah,
So I definitely heard of her there before, but she was one of, I think, the only woman to hold like an executive position at NASA at the time. So she
Wow.
was really ahead of her time in many ways, I think.
She's got a
wonderful.
Lego figurine too, apparently.
Lego?
Yeah.
so okay, so Nancy Grace Roman can ride with the Lego Batman in the next Lego movie, right? That would be a lot of
Yeah, I
fun.
hope
That'd be
so.
awesome.
Yeah.
So, how does Nancy Grace Roman differ from the James Webb?
Oh, yeah. So actually, the Roman telescope is going to be similar size as Hubble.
Oh,
But what makes it different than Hubble or James Webb is that it's a wide field, primarily a wide field instrument. So it's going to look at a huge portion of the sky. It has a very large view of the sky with many detectors, and so it's going to do a different kind of science as what Hubble and James Webb necessarily are doing.
oh,
And there's also an additional instrument. This is the coronagraph instrument. That's a technology demonstration. If we want to be able to eventually, do something like imaging an Earth around a star like our sun, we have to really have exquisite, optics and control of the light coming into the telescope. And so this is a step in that direction.
cool. So, is that the area that you're working on? The this
That's
coronagraph
right.
thing? Okay, tell us about it. Give us this as technical an explanation as you dare from those of us who are untechnical about your field.
Sure. So the way a coronagraph works is that you are actually trying to block the light of the star so that you can reveal light that's very close to the star but much fainter. If you're outside on a sunny day and you're playing baseball and you're staring at the sun, you might get hit with that baseball. And what do? Usually you block out some of the light to reveal the thing that you're actually looking for.
Ah,
And we've done this very successfully with Hubble. We'll do this with James Webb. We've done it on the ground, but any imperfections in the optical system make it harder to do that. So if you have a perfect coronagraph and then you have any extra bouncing light in your system or coming into the telescope, it'll throw little bits of light around that might mask out the signal of like a planet. So
oh,
the really cool thing about Roman's coronagraph is that it has on board 2 deformable mirrors.
Oh,
So this is never been done in space. So inside the instrument, there are mirrors that are able to change their shape, and light will come in, and you can actually correct for the optical aberrations that are coming through the telescope.
wow.
And until you can reveal the area around the star and see a potential planet's light.
The mirror is actually changing shape in real time?
So the Roman primary mirror, the telescope's mirror, is not changing, but inside the instrument, the chronograph instrument, there are 2 mirrors that are changing,
Wow.
changing slowly, but it's similar how on the ground we have adaptive optics systems that sense the atmospheric aberrations and try to correct for those in real time. That process is a little bit slower on a space telescope. That's why we want to send things up into space. We don't have to look through the atmosphere, but you
Makes
still
sense.
can gain a lot by additional correction of that wavefront to make it as pristine as possible.
So even a tiny, tiny bit of light, like a millionth of the amount of light that would ordinarily come from a star, would drown out a planet.
It depends on how bright that planet is, right? So if you're looking for a planet that's a million times fainter than, or 100 million times fainter than the star, then yeah, you have to get all of that starlight removed out of the way. Yeah. Or
Wow.
as much as you can. Yeah.
Dang.
And if we understand really well how optics works, we can take advantage of clever masks like the chronograph plus the deformable mirrors to actually carve out a dark region around the star to reveal a planet. And that's what Roman is doing.
Fantastic. I love that. Now, you said it is being attempted on James Webb. Did you what is it that you worked on the James Webb, and what does it do? It sounds even
Okay,
cooler
so
than the coronagraph. Okay, let me put it that way.
so there's this funny little mask on the near infrared imager and slitless spectrograph called NGRST for short. It's called the aperture masking interferometry mode, and
Okay.
it looks kind of like it's a mask with a bunch of hexagonal holes, 7 holes, and
Okay.
what it does, much in again going back to the original topic, in the same way the Event Horizon telescope is pulling together different signals of light. Each
Mhm.
hole is the light coming through each hole is interfering and creating like a different pattern on the detector, not
Okay.
like your typical point source. And by changing the shape of the light that's coming in,
Yeah.
you become more sensitive to faint things around, a bright star, for example. So you can look for planets or brown dwarfs that are orbiting a star, and learn more about these kinds of objects.
Wow. Alex, this sounds not just sort of astronomically cool, like what I do with stars and planets and galaxies and stuff, but this is like seriously high tech. This is engineering. This is, really fancy optical stuff at its highest level. This is beyond me. This is remarkable.
The nice thing about it is that it's quite simple hardware in terms of the mask. It's just a piece of metal, but it really can give you an advantage in some of the interesting science you can do. And
It sounds simple to you. It sounds complicated to me, but that's fun. You are engineeringly trained as well as astronomically trained, right? You must have this sort of skill with machines and technology that I don't have for sure.
I did study engineering, but it was science that captured my heart, and so I've always been a little bit more drawn to the technical challenges of how do we actually do the science, and I love to be a part, my small part of that community in bringing amazing new discoveries to the world.
Fantastic. I love that. Yes. So all you engineers out there who are listening, come do astronomy. We're cool. Or something like that, right? Sorry, I'm showing my bias. Everyone, engineering is cool too. It really is, honest.
Yeah, well, you can do engineering for astronomy. You can do astronomy involved with the engineering. It's all connected.
I'm sure that's true. Your coworkers at Caltech at IPAC must range a wide variety of skills and abilities, right? Not just astronomy in particular, like what you have in terms of your
Yeah,
skills.
that's a good point. We have many astronomers, but also software developers, system engineering people. So a lot of missions that are worked on at IPAC involve, a scientist, somebody who's trained in astronomy research usually, and a software developer or more combinations of those kinds of things. So it's actually quite nice because, it's nice to combine people with different skill sets to produce something even better.
Well said, well said. I love that concept. So how much longer do we have to wait before we get to see all this cool Nancy Grace Roman telescope stuff?
So I believe the current launch is in 2027
Okay.
launch date.
Okay.
So we can keep an eye out for that.
All
So
right.
we'll have to get you back over and over again over the next 5 years and keep us posted on how it's all working, right? Okay. So, Alan, can you feed us another question that Alex can answer?
Yeah. So here's another question. It's from Jayla from North Andover. And the question is, as an astronomer, what is the most exciting part of your job?
That's a really good question, and I think there are multiple answers, but I'll share some of my top choices.
Yes.
Okay.
So Uh, as an observational astronomer, I would say that at least pre-pandemic, one of the most exciting things about my job as an astronomer was traveling to telescopes in different parts of the world and being on top of a mountain and just taking all of that in. There's really nothing like that. But recently, and actually, I was outside of astronomy for a couple of years and have come back. And recently, I've come to really appreciate how collaborative astronomy is. And I find that
Oh,
so refreshing and so exciting. There are so
Oh,
many people who love to contribute public tools and who just want to collaborate and want to, figure out how, to combine their skills and do a better job together. And I think that's really my answer is how wonderfully open and collaborative
yeah.
astronomy is.
yay! So glad to hear from that point of view, Alex, that we're a collaborative, happy bunch, right? I mean, obviously we have our issues, but
For the
that
most part.
yeah. Is that what brought you back to astronomy after having left it? The desire to find that kind of environment, or was there something else, like the draw of those mountaintops, that really made you want to come back?
Yeah, I would say that was a big part of it. It's very it's just it's a very good feeling to know that you're not just working for your day job. In a sense, you're part of a community that's not afraid to share what they're doing because of whatever reason, proprietary or whatever reason.
Mhm.
Yeah.
It's very liberating, and I really missed being part of an open community like that.
Oh, it's such a good feeling. Oh, sorry. Let me not break into song too much. But that's great. Wow. I've been enjoying that environment my whole career, not even realizing what special coolness that has. Thank you, Alex. Boy, that makes my day too. Whew, I'm happy about that. What are you planning to do, say, for non-science stuff for the next, you're in Southern California, you get to relax for a little while, like in addition to this hard work that you're going to be doing for the next 5 years before we launch. Do you have other things that you like doing?
Yeah, I have to say that having just moved to California, it's a great place for outdoor activities.
Mm.
I'm getting really into hiking.
Ah.
I'm a swimmer, and there's so much swimming between the ocean.
Yeah.
There's an outdoor pool every square foot. Um, so it's really been a great place for getting outside and just getting some fresh air.
That's great. Are you able to go from pool to pool? I mean, like, hi, can I borrow your pool and just swim? Oh, thanks, and go to the next one. Hey, that would be
Not
fun.
quite, but lucky for me, the building I work in is right around the corner from the Caltech pool, so I'm pretty lucky
That's
for that.
fantastic. Oh, that's great. Um, Read any good books lately?
Uh, I have to say, like, this is a great time for science fiction. I've been getting really into reading, especially during all the extra time spent at home over the last 2 years,
Yeah.
and there's so much good science fiction that's been published recently. But in particular, I recently read Parable of the Sower last
Oh,
year. This was
Octavia
That's great.
Butler.
Yeah,
Yeah.
this was right around the time I was thinking about changing jobs, and I think it was a big, motivator for me. It was an excellent book, and I definitely recommend that
Wow.
one.
Alan,
I'm
you've read
definitely.
that too?
I've read that. I read
Okay.
that actually probably last year also.
Oh, well, so it seems like a good pen. So it is science
Yeah,
fiction. I've heard of it and I know about it, but I haven't read it. It's science fiction. And Octavia Butler, was she a scientist as well, or a climate scientist or something, or just a
Octavia
very
Butler was a science fiction writer, and some people call the work also like speculative fiction. I think that's also a good
Yeah,
categorization.
oh, okay. And it like outlined society in such a way that made you want to come back to astronomy during a pandemic.
Yeah, so
I love
I
it. I think it's great.
there's something about the amid a world, a society that's kind of collapsing and everything
Oh,
is falling apart,
oh,
having the protagonist, a young woman, uh, still believing that we belong in space, that we belong among the stars,
oh,
was just very, very important for me to hear at that time, when it felt like, what's the point of anything that I'm doing right now? What's the point of any of the work that I'm doing? And it was
yeah,
okay to still have that dream and to still, you know, have a love for astronomy, and that was
definitely.
important for me.
wow, that is so cool. Alan, you would agree this is like the theme of
Yeah,
this book?
yeah. So it's cool. It's sort of a different kind of hero than a lot of science fiction stories have. So a lot of science fiction stories, you either have the, you know, action hero equivalent, like Luke Skywalker, or you have the one who's primarily a research scientist or someone like Mr. Spock. Um, and here the hero is she's not really either of those archetypes. She's more of like a spiritual prophet type person, but from a sciencey perspective. And I really think that was very engaging writing that way.
Wow, I love that. I guess it's not cheesy at all to say that astronomy and thinking about space exploration or just studying the universe can indeed be this uplifting thing. Um,
Yeah,
uh, it is. I know enough about the book that it's describing a dystopic future, and yet it is astronomy or the love of space or humans in space that is inspiring perhaps the salvation of our species or something. Wow, that is so cool. Well, until we get you back, Alex, is there some way we can keep track of what you're doing, how you're doing it? Are you on social media? Do you do that sort of thing?
I'm not much on social media, but you can, of course, keep an eye on Roman Space Telescope. I know we have a little bit of time before it launches, but lots
yeah.
of exciting developments. IPAC has a website, and there's also NASA websites for Roman Space Telescope, and that's what I'll be spending most of my time on.
Oh,
roman.ipac.caltech.edu.
okay, perfect. Wonderful. Thank you so much. Well, okay, we have already agreed we're going to have you back again. Thank you, Alex, Dr. Alexandra Greenbaum. Alex, thank you so much for being with us today. We really, really appreciate it. Thanks so much for being here.
Thanks for having me. I had a great time.
Allen Liu, our wonderful co-host, thank you for everything. Really appreciate it.
Glad to be here as always.
And thank you to you, all of you out there, for being part of our show today. If you like what you hear and see, please support us on Patreon. And as always, thank you for being a part of the LIUniverse.